We have another example on the board. This time we are going to analyze OR gate. Again, we're supposed to determine the output waveforms when the switch is open and when switch is closed. When switch is open, first input is connected to the pull-up resistor and VCC. It means that this input is going to have logic 1. Next, you're supposed to look at the truth table of OR gate. If you will notice that if at least one input have logic 1, output is automatically 1. So without a long analysis, you can say that when switch is open and one of the inputs is receiving 1, output is automatically 1. Okay? So this is the answer for the problem when the switch is open. When switch is closed, okay, I'm going to have over here logic 0 because ground is representing logic 0. Now I'm going to apply the input waveform to this input. In order to complete the timing diagram, you're supposed to draw the dashed line at every single transition from 0 to 1 or 1 to 0 of the input waveform. Now, we have 0, 0. 0 or 0 gives me 0. That's why I'm going to write over here 0. 1 or 0. 1 or 0 gives me 1. That's why I'm going to write 1 over here. 0 or 0 is 0. 1 or 0 is 1. 0 or 0 gives me 0. 1 or 0 gives me 1. 0 or 0 gives me 0. Now I can draw the output waveform when switch is closed. So I have 0, 1, 0, 1, 0, 1, and 0. Please notice that the output waveform is identical like an input waveform when switch is closed. So simply when you close the switch, you pass whatever comes to the input to the output. So these two waves are the solutions to my problem.